Welcome back, and I've got another fun experiment for you today. It's one you can try at home and it needs very simple apparatus. All you're going to need is a ruler and a piece of paper. You'll notice that Bjork the bear is not with us today. He's off on one of his world travels, and more of that later. So all you've got to do for this rather nice little experiment is tear two strips off the paper in different directions, one going across the top and one going down the side. So you can get your ruler and tear off a ruler's width that way and tear off a ruler's width going the other way. So it doesn't matter that they're not the same length, and if you want to, you can make them the same length by just kind of trimming it down like that, making it a fair test. So one sheet of paper has gone from along the top, and one sheet has come from the edge. And it's what you do next that's really strange. So now you've got your two strips of paper, lie them on top of each other and line them up. And then here's the interesting bit. Hold them at one end and just let them droop like that. Well, that's not all that surprising. But then turn them over and see what happens. So I've got them hanging like this, one sheet on top of the other, and I'm now going to turn them upside down. And that's really rather strange that they separate, they come apart from each other, but when I turn it back, they sit on top of each other. So what's going on here? So this effect is a rather strange one. And what's important to know for the explanation is these two strips of paper came from different places on your sheet. So if the sheet was like that, one of them came across the top and the other strip came from down the long side of the sheet of paper. Now, what you have to do, of course, is remember which is which. But when I do this, I know that this top one here bends differently from the bottom one and must have come from a different part of this paper. So which bit came from where? So by looking at the sheets that I tore off, and you can label them if you want, this one here that bends more, it's not as rigid, it's more flexible, actually came from along the top of the sheet. And the one that's stiffer, the one that stays up here, came from down the long edge of the sheet. So paper must have different properties depending on which direction you cut it off the sheet. So what I need to do is explain why that is. So the key to explaining how this works is knowing a little bit about how paper's made and what it's made out of. Paper, as you probably know, is made from pulp, and pulp is a series of long, thin fibres, a bit like hair, a bit like spaghetti, but they usually come from wood pulp. And when the paper's made, the pulp is turned into a mush. It's a liquid mixture mixed in with water, and it comes out through a nozzle. So they pour the pulp in, it comes out through a nozzle, lands on a sort of drying table, which has got holes in it. The water comes through, and what comes off is a wet sheet of pulp that can then be pressed, calendared they called it, and dried and turned into a piece of paper. But the interesting thing is all the mixed up paper fibres line up as they come over and out of the nozzle. So on the Fadrinia paper machine, the fibres are coming through the nozzle and they'll line up in what's called the machine direction. And the machine direction is along the top to the bottom of the sheet. Whereas, if you look at the fibres in the machine direction, the cross machine direction has fibres lying next to each other rather than lying in a long straight line. So paper has different properties in different directions, and in this case at 90 degrees to each other. So now you know a little bit about machine direction with the fibres lining up and cross machine direction where they're sitting side by side, as it were. This is the explanation for this experiment. When you take a sheet of paper and you bend it this way, you're actually flexing the fibres and it's slightly stiffer so it doesn't droop as much. Where if you bend it this way, and sometimes you can even feel this, It bends more easily because the fibres are sitting side by side and you're sort of bending within the gaps of them. And this is an important thing to know if you bind books. So if you print and bind books, you're going to have to fold paper. And if you're going to fold paper, make sure you fold it so that's the machine direction. In other words, you're bending around the fibres lined up. If you were to fold the pages and bend them in the direction the fibres are lying, in other words, the machine direction like that, that's when you see cracking, etc. forming. So someone who prints books and then binds them will know to always make the folds in the direction that the fibres are lined up so it can be folded again and again without cracking forming. So I hope you enjoyed that little experiment and learnt a little bit about how paper is made and the fact that it's not isotropic. It doesn't have the same properties in all directions. It has different properties depending on which way you cut it. Anyway, try that at home. Let me know how you got on, and I'll have another video for you soon. See you then.